Hello students, now let us go for one more experiment in electrical machines 2 laboratory, that is in the 5th semester. So this particular experiment is on 3-phase squirrel cage induction motor. So the test name is conduction, that is no load test and rotor block test on 3-phase squirrel cage induction motor, and the main aim of this experiment is to draw the circuit diagram by conducting no load test and rotor block test on 3-phase squirrel cage induction motor, and then we have to predetermine various parameters such as efficiency, power factor, load current, etc. from the circuit diagram that is drawn based on the results of no load test and rotor block test on 3-phase squirrel cage induction motor. So before going to this particular experiment conduction, first let us see the circuit diagram related to 3-phase induction, that is no load and rotor block test of 3-phase induction motor. So this is circuit diagram for blocked rotor test condition. So it is equivalent to what? Short circuit test. So this is what the 3-phase squirrel cage induction motor, and these are the measuring instrument, and this one is 3-phase variac. So here first we need to give 3-phase input to the 3-phase variac, and from the output of 3-phase variac the connections are given to the squirrel cage induction motor as shown here. That is, from one output terminal of auto transformer, first output terminal is given to the ammeter common and voltmeter common, and the ammeter other end, that is 10 amps rating, is taken to M, and L is connected to junction of A1 and C2. Similarly, voltmeter other end is connected to second output terminal of auto transformer, and the same is also connected to common terminal of the 2 wattmeters. Actually, we can take 2 single phase wattmeters, or you can also take a 3-phase wattmeter also. That means double element wattmeter can also be considered. Here we have considered double element wattmeter, and in this double element wattmeter M and V should be shorted. M and V should be shorted, and this is the C terminal. So these are internally connected, and then they are connected to auto transformer output terminal, and then the junction of C, that is B2 and C1. This is C1 and B2. So the next, from the third output terminal of auto transformer, it is connected to M, and L is connected to the junction of B1 and A2 as shown here. And you can observe there is a brake drum for this induction motor, because we need to block the rotor. So for blocking that rotor, we need to apply initially heavy load on the rotor so that it will not rotate for the rated current that we are going to get. So after this is how the circuit diagram for blocked rotor test. And once if you are able to understand this particular blocked rotor test circuit diagram, then we go for nameplate details. From the nameplate details of induction motor, you can see they are written here. Kilowatt rating is 3.7 kilowatts, ampere rating 7, voltage 415, and RPM 1440 RPM. So radius of the drum is considered as 0.145 meters, and of course here at this moment no need for that, because for drawing circle diagram radius of drum is not required. And we need to see that what is the maximum power rating, current rating, and voltage rating. Once if you are thorough with this nameplate details, the same can also be obtained on the nameplate as shown here. The same can also be obtained from the nameplate that is shown here. Next, once if we are thorough with the nameplate details, then let us decide the ratings of the ammeters. Since we are conducting under the experiment under blocked rotor test, which is equivalent to short circuit test, and the current rating of this motor is 7 ampere. Therefore, the range of this meter should be 10 amperes, and the type of instrument is MI. Similarly, the range of this voltmeter, so under rotor block test, which is equivalent to short circuit, therefore we can we can give it to, since rotor block test, that means short circuit condition, we can connect either 300 volts or even 150 also. So that can be connected here. Is it clear? So and the type of instrument is MI. 1 minute. No. First we are going for rotor block test now. For that we need to connect voltmeter to 250 instead of 500.
Rotor block test, huh?
Yes, ma'am.
Load estimate.
So once if you have to either can go for 150 volts, because short circuit condition less voltage is observed, either 150 or 300. So 10 amperes. Once if we are thorough with the ammeter rating and voltmeter rating, then we can go for rating of this particular wattmeter, double element wattmeter. That means 3-phase wattmeter. So we can say 10 amps, 150 volts, or another value will be there, and UPF wattmeter. This will be the rating of double element wattmeter. So after giving the ranges of ammeter, voltmeter and wattmeter, then we go for giving connections as shown here. See here, this is 3-phase variac, where there is a knob here, and the input to this 3-phase variac is from 3-phase supply R, Y, B. So R is connected to input terminal of auto transformer R, and Y is connected to Y of input, and B is connected to B of the 3-phase supply. Now the output of this auto transformer as shown in the diagram, this is the output terminals. So from one terminal, first terminal of 3-phase output, see here, this is first terminal. From here, two connections are taken, one to the ammeter as shown here, ammeter common, please observe, and the other one is connected to voltmeter common as shown here. So voltmeter common. Voltmeter other end is connected to Y, because it's a line voltage, you can observe. Voltmeter other end is connected to Y terminal. This is Y terminal. Now ammeter other end, that means 10 amps ammeter, 10 amps side I am going to take. This is connected to, you can observe, ammeter other end is connected to M, that is, this is M terminal. Since it's a double element wattmeter, MV is to be shorted. This is M and this is V. You can observe 250 volts. This should be shorted. Then L of this wattmeter, you can observe, L of this wattmeter is connected to A1 C2 junction. So L of this wattmeter, see here, this is L of the wattmeter is connected to A1 C2 junction. See here, A1, this green wire connected to C2 junction. So that finishes first terminal. Next, second terminal of output of transformer, one is already connected to voltmeter, then the other one is connected to, please observe, the common. Other one is connected to common, and the same it should be connected to this second terminal of auto transform, already it is connected, shown here. And from this common, it should be connected to junction of C1 and B2. Please observe, it is connected to junction of C1 and B2. Please observe, this is C1 and B2 junction. So this is connected. This is second connection. Now the third output of auto transformer, it is connected to M. See here, third one is connected to M. Then L is to be connected to, so M is connected here, and MB is shorted, same here, M and V, and then L is connected. L of this is connected to B1 junction, that is, see here, B1 and A2 junction. You can observe it, B1 and A2 junction. This L is connected to here. So this finishes the circuit connection for no load test and rotor block test on 3-phase squirrel cage induction motor. So once if you are thorough with this, before under to rotor block condition. So we are going to perform now rotor block test. For this we need to see that the motor is to be loaded at, in general, a load at which the motor will not rotate even if you apply rated current. So that condition is to be applied. So load is already it's loaded, and then see that this should be at its minimum position ensured, and now turn on the machine, turn on the supply, and slowly you need to vary the ammeter. You can observe the rated current of this particular induction motor is 7 amperes. Until we get 7 amperes, it should be varied. See here, this is 7 amps range. So we got it 7, and you can observe the voltmeter shown is what? So rotor block test readings. Rotor block test on 3-phase squirrel cage induction motor. So voltage rating is, you can closely observe, it is something around 74 volts. It is connected to 300 straight away. Voltage you are getting 74 volts, and the current rating you are going to get 7 amperes. And wattmeter rating, you please observe under short circuit condition, it is one division is 40. So it is 280 to 320 in between. So something around you will be getting wattmeter rating as 300. But there is a multiplying factor for this. You can calculate this multiplying factor as directly from here also. You can closely observe. We have connected to 10 amps, and the voltmeter we have connected to, shown here it is 250. So 10 amps for 250 volts, the multiplying factor is 2. So that means the wattmeter reading is to be multiplied with 2. So this gives you 600 watts under rotor block test condition. Apart from this, you can also calculate the multiplying factor as shown like this. Voltmeter connection is 250, current 10 amps, and power factor is nothing but UPF wattmeter. So 250 into 10, that is nothing but what? 2500. And what is the full scale deflection? You can observe 2500 full scale deflection. So V is 250, current is 10 amperes, and power factor is 1. So VI cos phi, 250 into 10 into 1 divided by the full scale deflection is 2500. If you see 2500 divided by 2500, nothing but 1. But it's a double element, therefore again you have to multiply with 2. So that is how you are going to get the multiplying factor of this wattmeter for this particular connection is what? 2 under rotor block test condition. So after taking down the readings for rotor block test as shown here, please note down these readings again. The current rating is 7 amperes, voltage rating is 74 volts. 74 volts. This finishes rotor block test on 3-phase squirrel cage induction motor. Is it clear? Stop.